Alright, in this next lesson, we're going to be looking at graphing quadratic equations. Okay? Graphing quadratic equations. And we're going to look at a couple of examples. This is the first example we're going to look at, y equals x squared minus 4. Alright, now as we're graphing equations, we're going to look for a couple of things. Alright, the first thing that we're going to look for is, and we can actually get them in any order, but let's start with the y-intercept. Okay. Now you may remember from the very beginning of the year, we got the y-intercept by making x equal to 0. Okay. So let's put x equal to 0. So we're going to say y equals 0 squared minus 4. And that math is pretty easy, right? 0 squared is 0 minus 4. So y equals negative 4. So we can put our y-intercept down at negative 4. Okay? And then we can go on and let's do the next part. We're going to find now the x-intercept. Okay, now to get the x-intercept, we're going to make y equal to 0. Okay, so we're going to go back to our original equation. We're going to say 0 equals x squared minus 4. Alright, now in this one, there's a couple of different ways that we can solve this. We can solve this by factoring, right, like we did a couple of chapters ago where we break it up into sets of parentheses. We can solve it, if there's only one x term, we can solve using square roots, like we did 2 lessons ago. Or you can solve using the quadratic formula. Okay, now the easiest one in this situation is probably using square roots, right? If I get the x squared by itself, I add 4 to both sides, and I get 4 equals x squared. And then to get the x totally by itself, I'm going to take the square root of both sides. And of course, when I take the square root, my answer is plus or minus 2 equals x. And so now I can put my x-intercepts on. The x-intercepts are on the x-axis. So I've got 2 and negative 2. Now make sure you're drawing this graph in your notes. Okay. Now, when we have the x-intercepts, the cool thing about the x-intercepts is that they're always going to be the same distance away from what we call the axis of symmetry. Okay, so if I can find the place that's right in the middle of my x-intercepts, okay, one way to do that is just by looking at the graph and saying, oh, there's the middle. Or you can average the two numbers, 2 plus negative 2, and then average it, divide it by 2. Now in this case, 2 plus negative 2 is 0, and that gives me 0. Okay, that 0 is the x value of my vertex. Now when we're looking at quadratic functions, the vertex is very important because a quadratic graph is always a curve. Okay, and the vertex is either the lowest point or the highest point, and that's where the curve either stops going down and starts going up, or it stops going up and starts going down. And so in this case, the x value of my vertex is at 0. Now if I want the y value, I put that in. Now I've already done that in my y-intercept here. We'll look at an example later where that's not the case, where we have to do something different. But in this case, I've already got my vertex. So this one is both my y-intercept and my vertex. Okay? Now what I'm going to do is I'm just going to get a couple more points. And to get those couple more points, I'm just going to use a table. Okay, I'm going to put x values in and y values out. Okay, and I can just pick a couple of points. Now the cool thing about this is the vertex is always on a line that we call the axis of symmetry. Okay, it's always a vertical line. Okay, we call it the axis of symmetry. Okay, and the vertex is always on that line, and the axis of symmetry acts like a mirror. You'll notice that one x-intercept is 2 spaces away over there. The x-intercept is 2 spaces away on that side. So any points I find on this side are going to be mirrored over on the other side. Okay, so I'm going to pick some other numbers. I'm going to take 1 and 3 and maybe 4. We'll see if 4 will fit on my graph. I'm not sure how high this is going to go, but let's put 1 in for x. Okay, so if I put 1 in for x, that will give me y equals 1 squared minus 4. 1 squared is 1 minus 4 is negative 3. So if I put 1 in for x, I get negative 3 out for y. So that means that point right there, 1 comma negative 3. Now using my axis of symmetry, since that's one space over, I can put a mirror image on the other side there. Okay, now let's go ahead and plug 3 in. Let's put we already know what it is. If I put 2 in, that'll give me 0, right? So let's try putting 3 in. So let's go y equals 3 squared minus 4. 3 squared is 9, minus 4 is 5. And so if I put 3 in, I'm going to get 5. Again, that's 1, 2, 3 spaces over. So using this mirror, this axis of symmetry, let's go over 1, 2, 3 spaces. And now you should be able to see what's beginning to look like a pretty nice curve. Goes down like this, just like that. At the vertex it stops and comes back around the other way and goes straight up like that. Now it keeps on going, so don't stop at these points, because if I put in other numbers and other values, it would keep on going and going. Alright, so that's our first example. If you're confused, that's alright. You can either go back and watch it again, or you can go on and try taking a glance at the next video, which is going to do the same thing.